So at this point, let's just remind ourselves, center of mass is a pretty important property of an extended system. We have the parallel axis theorem, which allows us to express the moment of inertia for rotation about an arbitrary axis in terms of rotation about the parallel axis that passes through the center of mass, plus all the mass times the square of the distance the axis was translated. Okay? And so clearly this is going to tell you that the minimum moment of inertia does what? The minimum value of the moment of inertia will occur for what condition? Yeah, when the axis passes through the center of mass. Anywhere, it makes sense. The center of mass is trying to describe the point where the mass is sort of balanced around. If you start moving away from there, and what you're adding up is the distances squared to the different mass points, that can only end up growing if you've moved away from the minimum point, which is the center of mass. This term here is the kinetic energy associated with rotation of an object about its center of mass, so that's the spin kinetic energy, and this is the kinetic energy associated with translation of the center of mass. We showed this before, and didn't even rely, this decomposition in terms of what's the center of mass doing and what's the motion with respect to the center of mass didn't require us to use a rigid body. And lastly, we've just shown orbital plus spin angular momentum gives you the total angular momentum.